I changed my mind. We're going to start right now. Hey, everybody, it's Discovery Hall. It's another Discovery Hall video, and we have another geologist today. Look at this guy. Andrew Sadowski is with us. We're going to step outside, take a little walk as usual, in between the raindrops, and then we'll look at some of Andrew's work. So thanks for joining us. I hope you enjoyed this video. I don't know if you realize it, but this is your 4th appearance on this YouTube channel.
I didn't know.
So you're a recurring guest, and for those that have not met you before, they assume, I guess to this point, that you work at Central Washington University, which is true physically, but are you employed by Central Washington?
It's kind of a fair assumption. I have an office here.
Yeah.
But the person who pays the bills is the Department of Natural Resources, so DNR in Washington State.
Oh, okay.
But my appointment here is like an interagency agreement between Central Washington University and the Washington Geological Survey and the DNR. And so that has kind of stationed me here. And there used to be geologists kind of stationed in different parts of the state. Even some entire geological surveys are, at a university.
Mm-hmm.
Just so happens that as the kind of state agency that we're based in Olympia with all the other Washington state agencies, or the main branches of those. And so yeah, I am part of the university and also not part of the university.
Well, we love having you here, and it sounds like you did see that Daniel Coe video that we did a few days ago.
Yeah, it's nice to see some of my old coworkers, or still coworkers. But
still coworkers, yeah. So there is a connection then between that Daniel Coe video. I think I'll put a link to that Daniel Coe video down below in the description so that you can get some context for this. That was my first time seeing the Washington Geological Survey space as an employee there. Were you working next to Dan or in that space for a few years maybe?
Yeah, I was working in that space kind of from 2017 to 2019.
Okay.
And my space relative to Dan's was kind of maybe 60, 70 yards away. So not super close, far enough to kind of walk over really quickly, but not far enough I wouldn't want to shout across all those people.
Oh, totally. Why did you move over here? Did you request that, or did your bosses think it would be better if you were based out of Central Washington for some reason?
I did not request it. It was kind of
well,
no, it was a really awesome opportunity that was presented to me by former state geologist Dave Norman.
Yeah.
And kind of going off, we used to have geologists stationed at different universities around the state of Washington. He thought it was a really good idea and helpful idea to kind of bring that notion back.
Yeah.
And so as he was kind of finalizing his tenure, he kind of ran the option by me, would you like to go out to here? And it's I had started making friends out in Olympia by that point and was getting settled, and I was like, no, this is really cool. So I decided to say yes, and I'm very happy with it.
Well, good. Well, again, we're thrilled that you're here, and COVID kind of put an interruption into kind of you getting to know our students to this point, but isn't that one of the objectives, that not only are you kind of physically based out of Ellensburg and you bought a house here and you're living here, but you're hoping to kind of have field assistants maybe that are coming through our program? Yeah,
the last few years, before COVID and even kind of during COVID,
right.
I had a field assistant who was from Central Washington University. My position here kind of presents really good opportunities for students and staff alike to kind of collaborate on research projects and hiring opportunities. We've hired kind of a fair number of Central Washington University students.
Over in Olympia, yeah.
Over in Olympia.
Right, yeah, it's been great.
So the field assistantship is a good place to get some first-hand experience in the field, or kind of do work that's kind of interesting to whoever wants to participate.
Mm-hmm. You were doing some mapping in Washington your first couple of years here, but it was not in Eastern Washington, is that right?
That's right. That was in Southwest Washington, kind of near the I-5 corridor, so Chehalis, Centralia, kind of east and west of that. Those two projects kind of turned into a much larger project that we got additional funding for, the Chehalis Basin project, and that was the mappers who came after me kind of mapped a lot farther to the west,
Yeah.
towards the Doty Hills, and
Yeah.
in parts to the coast too, even farther. So that it was kind of to look at a seismic hazard study in that area.
Was that a steep learning curve for you? You're plopped into Washington for the first time. You don't have any context. Maybe the units you're mapping are very different than what you had before.
Yeah, that first year was a real trial.
What kind of units were you dealing with?
Mostly Eocene sediments, so the Skookumchuck Formation and the Lincoln Creek Formation.
Mm-hmm.
These Skookumchuck's a coal-bearing unit. The Centralia coal plant is around there, and they're really close to some subbituminous coals. Talk about being plopped in. So right before 2017, I got hired here. I was mapping a lot of Oligocene tuffs and Miocene basaltic andesites in Nevada.
In Nevada for your master's work?
Masters and like post-masters
Okay.
work.
Yeah.
And so that's a big change from
God, yeah.
dealing with sediments and coal, and plus these sedimentary rocks look very, very similar, so it just kind of like ratcheted up the learning curve a little bit.
Well, and were you? I'm curious about that, because I would imagine just being absolutely overwhelmed if I'm just put in an area and I don't really have, I don't know which end is up, essentially. Did you have a Washington Geologic Survey person out there as a mentor, or did you just do a bunch of reading and then like, okay, here I go?
It was kind of both.
Uh-huh.
I credit the other geologic mapper who had been mapping in the area for a long time. That would be Michael Pullins.
Uh-huh.
And so he had been mapping quads kind of near the Black Hills, west of Olympia. And so he was familiar with a lot of the glacial stratigraphy and some of the bedrock stratigraphy there. And fortunately, that first year, him and I were mapping adjacent quadrangles, so I was kind of bouncing off his, institutional knowledge of, 10 plus years
Sure.
with the survey.
Sure.
And there was a lot of reading, Snavely and others. 1958 was such a great reference. It kind of focused on the coal geology. And in some regards, I was, taking a really closer look at that map and where it could be improved, particularly around the structural geology.
Yeah. Yeah.
Yep.
Well, so to transition to about what we're about to see. So yeah, we've made our little lap, and I don't know, have we seen one person the entire time? It's a work day. What is going on here? Don't comment on that, Andrew.
Thursday's a new Friday.
I gotta bug up my, yeah, exactly.
Well, we're kind of sticking with the geological hazards.
Even here in Kittitas Valley.
Yeah,
Oh God, I'm starting to get nervous now. Come on, man.
Well,
Just kidding. Just kidding, I know.
we're trying to better understand the geologic hazards in this part of the state and connect, there are some pretty significant faults on the west side of the state, and understanding how they transition through the Cascades is part of the drive, or at least that's the kind of academic, scientific drive for this project, besides
Yes.
practical.
So I mean, that's one thing that I'm very excited about, that you're finding, using the specialists that are collaborating with you, geophysics and other things, you're learning a bunch more about fault scarps and potentially activity on fault scarps right here, and not in Western Washington, but in Eastern Washington.
Yeah, and there's a lot of work to do.
All right, well, I have to take the scenic route, because we just visited with Dan, and here he is in living color. And I've had these up. I don't know if the students notice them or not, but they make me happy each time I walk in here. This is all from Daniel Coe in the cubicle, 5 cubicles down from where Andrew used to work. And this is the intro lab room, and we thought we would just kind of take advantage of this quiet time. So, all right. Hey man, you're a good sport. You didn't have breakfast yet, did you? We gotta. I should take you out.
Oh no, you don't have to do that.
Come on, let's have a buffet.
I've got a nice warm cup of coffee waiting for me.
You do? In your office?
I mean, eventually once I put the hot water in it. It's not waiting for me right now.
Okay. Good. Yep, got it.
So Ellensburg's there.
Good.
Craigs Hill Airport.
Airport. Wow, we have an airport. I should get out there and
And
take
then
it out.
the highway,
Yep.
90s over here.
Okay, freeway, good.
And then kind of zoom out more, and
Yeah.
the current map area is actually all the way over here. So if you can imagine, this map and that map kind of connect together. We're mapping this quad, and then we're moving south. So the quad next to this one is the Colockum Pass Southeast quad. This is the Colockum Pass Southwest quad. This just was published in late 2021, so December. You can find that on the WGS website.
Good.
In the kind of publications, navigate through publications, and if you want to link, maybe post a link, I guess.
I will definitely link that.
So kind of to orient your eye, this kind of large package right here, this kind of peach kind of matches this kind of peach here. So you'll connect this seam
Thank you, Dan
to that
Coe.
seam.
That's right.
Yes, thank you, Dan. The seam we're working on now is on the other side of this one, so this quad and then farther south. So if you look at this kind of index map here,
good.
We're working on Colockum Pass southeast and then the northern half of East Kittitas.
Got it.
Now what I'm gearing up for fieldwork this year is going to be the southern half of East Kittitas and all of Kittitas.
Oh, you're going south. You're going to be south of I-90 the whole, I don't know if I knew that. Wait a minute. You're going to be approaching Menashtash Ridge?
Yeah.
Oh, shit. Okay. Nice.
Yeah, I guess like another thing, so why didn't we go farther east? So if we go, 2 quads over, we're in another quad called the Boylston quad, and that quad has been mapped already by Jack Powell, so talk about mentors who've, got a lot of experience in mapping Columbia River basalts and mapping in this area. He and Bob Bentley, former professor at Central Washington University, worked together extensively in the 1980s, producing several geologic maps that cover portions of what I'm mapping lately. And so this Boylston quad that Jack has produced is unpublished right now, but it's complete. So we're trying to find a vehicle to publish that too. So it wouldn't make sense to kind of have me, go back out with a field assistant and map that, because that's already done.
Well, I'm happy to hear that you're taking a bunch of this, it sounds like you're taking a bunch of unpublished work by Jack Powell and Bob Bentley and getting it out there a little bit and ultimately giving it to Daniel Coe and giving it the whole Daniel Coe treatment?
Yeah, so
sweet.
Brian Sherrod is a USGS paleoseismologist.
More collaboration,
More collaboration, and he had dug a paleoseismic trench right over here. So in that neck of the woods, there was a fault scarp that he targeted, dug a pretty shallow trench. I think you were there. This is before I even met you.
Yep.
And they hit bedrock at about 2 feet below ground surface, so that's at that orange diamond. Now, fast forward to today, we have tools like LiDAR, and that Dan Coe video really highlighted a lot of the benefits of using LiDAR in an area that we map, and that's part of what goes into making our decisions on where to map is, do we have good LiDAR, recent LiDAR or not? So this fault here, in this trench, he found, like the next day, I dug it, and the next day there was a dead coyote in it. So they named the fault the Dead Coyote Fault. And it shows up really nicely on the LiDAR here. It's kind of tough because the base map on this map is kind of a mix of the kind of topographic map, the old topographic topo sheets, and some LiDAR.
There is some LiDAR on that thing.
But it's also covered with the geology. So this scarp is underneath this kind of fault symbology, this line with the boxes on it.
Okay.
So that was, mapping it out this well hadn't been done before, and we can kind of follow it, across the valley to over here before it meets another northwest striking fault. Which this northwest striking fault, down over here, we were able to map last field season in a lot of detail. So I'm kind of excited to show that this fault kind of connects with, another long structure.
Well, I can hear our viewers who live in the valley right now. It's like, what? There's a fault?
Yeah.
How nervous should I be? What do we know about date of past earthquakes on that fault? Anything?
Yeah. So it's kind of orient your eye again, Ellensburg down here, driving up along Reecer Canyon Road. There'll be a bend here, and you'll go up Robbins Road. Yep. So if you're driving up Robbins Road, you'll go up kind of a hill that seems kind of out of place, and that hill, which is past the canal, the North Branch Canal, the KRD
Good landmark,
canal. That hill is, formed by the scarp, or a reflection of the scarp.
Right.
And if you get on top of that, you'll even see some outcrops farther up, and you can even get like a fault surface. So this area, this little lozenge of purple or pink, is a really good outcrop along the road. That contains a fault surface of a kind of minor splay of that fault. Getting to your question, the alluvial fans that this fault is cutting through and deforming are generally pretty old. So we're saying kind of 450 to 500,000 years old. You know, this is not a historic kind of fault that's, you know, super active. You know, if it was, you know, diverting streams or, you know, diverting very recent flood deposits, then we'd be really concerned about it. It is worth knowing kind of in the context of, you know, the greater valley and, you know, the state, like how this fault may or may not play a part in that. And that's kind of the research we're doing right now. And a lot of that's kind of being taken over by Brian Sherrod, Steve Angster at the USGS, and other folks at the USGS who are in like the, you know, hazard assessment group.
So yeah, we're kind of, I'm asking a line of questioning that's not exactly in your wheelhouse. You're not coming in as a specialist and finding tephras or wood or something where you can get some kind of recurrence interval on that fault necessarily.
Not necessarily. I mean, the kind of standard method, or like the tried and true method, is digging a paleoseismic trench across these things, you know, mapping out the trench wall, seeing the different colluvial packages, collecting samples of charcoal, getting dates, you know, measuring the amounts of slip on these kind of strands in there. Digging paleoseismic trenches is...
That's not you.
Is not me.
Right.
And so I will, you know, I'll collect, you know, an age date here that might date this fan. I'll map out the location of the fault scarp. You know, I'll dial it in as much as I can, but then again, like, this research gets, you know, moved to another more different discipline.
That's beautiful. That's beautiful.
So,
what do we know and what don't we know about this blotch that just shows up in the subsurface? This is a your cross section and your map, and what does it have to do with the mapping on the surface that you did, if anything?
Yeah. So the talk I gave, I think, is posted online. So.
Oh, is it?
Yeah, that's it.
I'll find it.
Put that
Good.
link in.
Okay.
It'd be pretty cool.
On YouTube or something else?
It's on Central's site somehow.
Oh boy. Okay, I'll find it.
Anywho, so yeah, this VPA, which stands for volcanic pipe anomaly, is kind of located right around here.
I forgot that's what you called it.
This map is kind of a combination of things. It's got a LiDAR hillshade base map in the very background, so you can kind of see the landmarks. The color scheme is some aeromagnetic data that's published by Rick Blakely and others. It covers a really large portion of the state. The white contour lines are our recently collected microgravity measurements. So Todd and Megan collected these throughout the valley, and you can see where the stations are. Those are the kind of gray, black dots. What this map is showing is that there is a magnetic high underneath the valley sediments in this part of Kittitas Valley. So that kind of lights up really bit. So we're talking, you know, several hundred or, you know, a few hundred nanoteslas. Now, we draw kind of a cross-section line through here, or really a geophysical model line, which also overlaps with the geologic cross-section, which is down here. And the geophysical model, which is this, it's technically not a geological cross-section.
Yeah.
It is looking at the aeromagnetics and the gravity. So the dots in each of these panels are the observed points. The lines are calculated based upon this model here, where each of these colors, each of these geometries is a block of material that has certain geophysical properties that include density and other magnetic properties. I'm not a geophysicist, so I don't. This is more Megan's realm.
Right. And so which came first? Like, you're doing your mapping, there's no really surface expression of this weird VPA, I don't think, right? So you didn't say, wait a minute, something's funky here. Can we do some geophysics to understand what's going on underneath, or vice versa? Or like, why did this get done in conjunction with your project here?
This is kind of a happy coincidence.
Oh, wow, really?
Yeah, I mean, the kind of neat thing that's happening here, at least, you know, to the surface mappers' eyes, is that you've got kind of strands of faults that are of different orientations, kind of intersecting in this area. And areas of fault intersection are interesting for a lot of reasons. I won't go into all of them, but like in geothermal, these are, you know, potential targets for upflow of hot fluids. In groundwater, same kind of deal. Or at least you'll know like where, you know, parts of the aquifer might leak. You know, areas of increased secondary permeability are good to know about for, you know, whatever project somebody's working on.
Jeez.
So we didn't know this was, you know, anywhere here just based on the surface. And the aeromag, which this comes from, you know, once we took a closer look at the aeromag the last few years, we saw this like pimple and we're like, what the heck is that?
Exactly.
And it wasn't until we got around to modeling it that we began to understand what it was.
Well, we still really don't know what it is, though, right? I mean, we know it's there. What do we know about it? It's a diorite. Why does she think it's a diorite? She says diorite question mark, or you say diorite?
Yeah, diorite question mark, or you know, older basalt or granite diorite. So we're basing that lithological on densities of rock that would fit that, you know, area. Because again, like each one of these polygons in here has certain densities and certain magnetic properties. So in some cases, like the basalt at the surface, we can actually measure those actual numbers for density, for magnetics and magnetic susceptibility, et cetera. And those get plugged into the model. So it kind of constrains the model a little more, because if you had, you know, unrealistic values for these physical parameters, this model would be pretty, you know, unhelpful. But at least here, she was kind of seeing which densities could work for this area, I think.
Jeez.
And you know, it fit diorite. It's kind of.
It's got to be older than Miocene. It's not cutting the basalts.
That's our thinking. So if we can say much about it, it's pre-Miocene.
My God, we're not talking about Bolivia. This is the valley that I live in and you live in. I mean, it's so cool. And that's just going to hang there probably for a while. I mean, nobody else is going to work on this for a while, I guess. I don't know. Like, what would somebody mapping up Wenatchee or something find some structure and then kind of work backwards? Maybe you in 10 years? I don't know.
I don't know.
It'd be fun to. I'm so intrigued by that. My God.
I mean, one avenue of research could be the researchers or folks take a closer look at the aeromagnetic data and try to find similar features or similar magnetic anomalies like that, and compare them to this one. And maybe they're nearby or maybe they're far apart.
God.
Initially, I was thinking it might have been like a satellite Pluton for the Snoqualmie batholith rocks. You had said that it might be, you know, even older than that, relating to some Eocene material near
that's where
you know,
my
the
thought goes.
pinnacles in Wenatchee.
Yeah, I remember we were in the Naneum doing that video last November,
Yes,
and we're looking underneath the cake, and suddenly we're in a bunch of Eocene stuff. That's not that far away.
Yeah, I mean, that's what this kind of brown material is. That's the Eocene stuff too. Yeah, it's not that far away, but like looking for volcanic edifices that are exposed to the surface that, you know, also make a anomaly pattern like that would be kind of what you're asking, is like who's gonna look at that. Interesting,
super interesting. All right, I could go on here, but you know what? Thank you for this. Andrew's waking up, everybody. We're talking about VPAs now. All right, let's finish by, you know, there's not that many of us down here on the first floor, and it's nice to have a friend at the end of the hall. And yeah, we're coming out of COVID. We're trying to get back into some sort of kind of social flow in this building, especially this fall. I don't know, are you going to be out in the field on Fridays? It'd be wonderful to have you kind of hanging out with most of us on Fridays at noon, you know, before and after the seminar.
Yeah. That could be possible.
Okay.
I don't. It kind of depends on my schedule with you know, trips and stuff we're trying to plan.
I got you. Yeah,
things
you're
like
playing
that.
hard to get now. I get it.
Well, I want to. So.
I understand. Oh, look at this. Yeah.
So each of these maps comes with a pamphlet report that goes into more detail about the unit descriptions and even some of the structures. So there's more information in there than is on the plate.
Well, I'll definitely put that link on this video so people can really dig into your details. And here's Andrew, right? You know, this is the Student Union building, and all the groovy people are playing their music and everything. And I've said this to you before privately, but I want to do it publicly. You're an inspiration because you work so hard. You have so much pride in your work, Andrew, that it's just inspiring to be associated with you.
Well, thanks. I'm kind of nervous about this praise.
All right, so look at you, just brainstorming here.
Yeah.
All right. Oh, yeah. So
That's
here's an
yours.
example. Right. Oh, thank you. So you were looking for a master's thesis from Ron Owens, who I caught when I first got here, part of the Bentley Powell cult, and you digitized this. I'm curious. How did you digitize that so
just
quickly?
Put it in the printer, scanner, Xerox machine, and scanned it to my email.
We're cutting that part out too. That's going to make me look bad.
Sorry. This is going to be an interesting first cut. Like all of this.
I don't know. Like, so,
know.
yeah, this is a geologist. This is a field geologist. This is what a field geologist's office looks like. Can you
man.
get, so you're taking.
Found all the things I'm trying to hide.
So can you give us a sense of why you collect certain things and why these bags are here?
Yeah, so the bags down here, these very large bags, those are samples for detrital zircons. So they'll get sent out and separated and then ran through an ICP-MS, I think. I could have that wrong. But basically, we're doing uranium-lead geochronology to either kind of assess a maximum depositional age, or to look at the age spectra and compare, where the sourcing of these rocks might have come from.
These are samples from last summer with some of the sedimentary interbeds maybe between the Columbia River basalt lavas?
That's right. So most of these are Vantage sandstone or Coleman sandstone. As I look at the unit labels, I think they're mostly Vantage.
Okay.
And that's kind of a pumiceous to micaceous sandstone and siltstone.
Great.
Even has some fossils in some places, mostly just like plant impressions. So like that.
Oh, sure.
It's not.
It's a leaf.
Yeah, leaf.
Miocene leaf.
And
our eye is drawn. Maybe you were about to say something about this impressive sample.
Yeah, this is a really nice sample of haloclastite, or maybe more specifically, we've got basaltic glass, which is this kind of black material here, something akin to obsidian.
Yeah.
And then the material elsewhere around it is the weathering product of that volcanic glass called palagonite. And so together, palagonite and basaltic glass are kind of descriptive terms, and the haloclastite is the interpretive term for this deposit. And all haloclastite really means is that a lava had entered water and got quenched really quickly and produced this rock. So if you see this out in the field, or if you see something that has like pillows, like pillow basalts, we would know that there was a water-lava interaction at some point in the past.
Why did you bring that one back?
I think it's like a spectacular example of that. Like only in textbooks will you find, really nice samples like that.
Totally agree. Do you need a bigger office?
No.
What else are you doing in here? You got a microscope in here.
Yeah.
How are you using that?
So this is a petrographic microscope. So in addition to the rock samples that you saw on the floor and on the wall there, we will collect petrographic thin sections that look something like this. So
can we pull one out just for us, please?
So these are coming in kind of two flavors. One flavor is the kind of sandstones that I've had impregnated with blue epoxy, so we can kind of see where the pore spaces are. Also, the other flavor is kind of this clear epoxy, which are the basalts. So sedimentary units for blue, and then these are the volcanic units. And so you'd kind of slip one of these, onto here, you turn it on, focus the ocular, and then kind of see what minerals, which are microscopic, compose the rock that we're looking at.
Does that end up in your map or your publication somehow?
Yeah, that kind of enters into the unit descriptions, and maybe even will help us figure out how to distinguish some of these very similar looking basaltic rocks. So like the Grand Ronde, which is most of what we've been mapping the last few years, is an aphanitic apheric basaltic andesite, so no phenocrysts. It's kind of like very monotonous looking.
Okay.
But there are some differences that we're finding. This is a LiDAR hillshade.
So what do the different shades of gray mean?
A couple things. So the darker grays are the 10-meter DEM, digital elevation model, provided by the USGS. The lighter grays are, the most recent LiDAR that the state has. So where you see the darker grays, it's kind of where we have data gaps.
We don't have LiDAR yet.
Sort of. I mean, this area, this large blocky area down here is an exception because there is LiDAR there.
Okay.
Over the military base.
Okay. So you're mapping this summer in an area that doesn't have the best LiDAR?
Well, I do have access to.
Oh, look at you,
so I'm
Mr. Fancy Pants.
Some of that.
Oh, is that the firing range? Is that
Yeah.
Army stuff?
This
okay.
is the Yakima Training Center down here.
I got it. Okay.
So we like this map on the left here. If you can see my pointer, so this area there is this map there.
Yeah.
This map here is this map there.
Okay.
This is the map that I'm working on, and you saw on Dan Coe's screen recently. And then here's the East Kittitas Quad and the Kittitas Quad. So like this kind of area here, if I like.
Oh, you're in Badger Pocket this summer.
Yeah, pretty darn
Wow,
close.
I didn't have that. And oh, beautiful. Is there an obvious fault? I'm obsessed about fault traces, I guess. Is there a known fault running through there that you might do the same kind of improvement upon?
Yeah, so this is the Boylston Mountains. Is this kind of finger to the north of Badger Pocket.
Okay.
There are some kind of curious looking scarps around here, and we did some preliminary mapping already in this area that is kind of the northern half of this quad. So if you can kind of see the text of East Kittitas right there, you don't have to zoom in, but like basically if you could draw like a horizontal line through here,
yeah.
We've mapped a good chunk of that north. So what that kind of looks like, this one shows up. So these are kind of the pre-Dan Coe maps. The colors that are purples are the greens on this map.
Oh yeah.
Yeah, down here is kind of the Badger Pocket that you're referring to, and we're preliminarily there is some sort of northwest striking structure in this area. There's also kind of a fair amount of like these northeast striking structures. This one happened to also be trenched by Brian Sherrod and I think a poster with Elizabeth Barnett and Brian Sherrod talking about the Johnson Canyon Fault.
That cuts Mazama.
Yeah, there is some, I think, Mazama ash down over here.
I did a video on it back when he was doing that. I'll show it to you. Well, Andrew, thank you for your time.
Yeah, my pleasure.
I really appreciate it. And I'll edit some of this down, but this is great. I've just had a blast this morning, so thank you.
Yeah, my pleasure.